Hello followers, Crofty here against an exciting backdrop of post-it notes on my refrigerator. Couldn't live without them. Following on from what I said yesterday, here's an example of a GC valve spring seized absolutely solid. Can't even separate the coil pack, and I can see the coils themselves are shiny because they've been rubbing together, bone dry with no lubrication, overheated, barely movable, run out of oil. Same thing can happen if your oil is contaminated, as I said in the previous video, with petrol. Very common on turbocharged engines. Full race engines, very wise to check the oil quality. Go to someone who can analyse oil after each race, or change it every race if you can afford it. Use a good grade of oil. My personal preference is Valvoline VR1 semi-synthetic, as it used to be called. They've adopted all sorts of fancy names for it, synthetic blend and God knows one. VR1 10W60, excellent oil, actually made from Pennsylvania crude. So, what is synthetic oil? Well, it's natural oil blended with synthetic oil. Simples. A subject I forgot to mention yesterday when I was talking about installed height and how its influence on poundage is immaterial. One must, of course, check that for a given camshaft lift, be it 10, 11, 12, 13 millimeters, whatever, that at maximum lift the coils don't become bound. In other words, touch each other. The minimum safety distance between any of the coils in the pack, if it's a 2-pack, single pack, whatever, I would say probably 1 millimeter minimum. And of course the installed height of the spring and the height of the valve tip above the spring platform, that's the section in the cylinder head where the spring base sits, has a major bearing on this. So do check that. It's dead easy. Just put the spring in a vise, squeeze it, and do the measurements with a micrometer. Dead simple. If you've got 1 millimeter between coils at closest proximity, for the valve, rather the camshaft lift that you've got, you're laughing. Job done. I talked about excessive poundage, and I brought home a rare and ancient thing, which is a genuine ex-Vauxhall DTV Chevette HSR camshaft. Now there's a story. I know the story, and few do. I know why they broke so many engines. Here's the coil pack, right? They're not interference springs, not at all. There's about, probably radial clearance, about 3 millimeters between them. So they have no protection against the waviness that you get in a spring in operation. Again, there's good YouTubes of videos of this, where the inner spring wobbles around and the outer spring bounces all over the place. I'm not talking about valve bounce here, but the spring itself deflects like this, waves around like a snake. Now, Vauxhall HSR teams, the DTV Chevette teams, I mean, they were independent. Ultimately, they had Vauxhall backing. To begin with, they were independent. They had terrible problems with valve train. Terrible problems, should I say, with valve train. Valves hitting pistons, bending, breaking, etc., etc. And they went harder and harder on the valve springs because they thought harder valve springs will control the valve train, prevent valve float. Not so, not always the case. This spring pair, which is completely undamped, are so stiff I can hardly compress them. Well, look, obviously there I'm pressing the outer spring. It's unbelievably stiff. You could lift up my Range Rover with that spring and it wouldn't move at all. The inner spring, almost the same. They are, as they should be, contra-wound, so one's wound one way and one the other. Didn't work. Didn't stop the valve float problems. Valves kept hitting pistons. So they assumed then that the problem must lie with lubrication, inadequate lubrication. So what did they do? They drilled the camshaft. This cam is through drilled, so it drilled from one end to the other and cross drilled to feed more oil into the cam follower and a valve spring. Didn't work. Of course it wouldn't work. Lack of lubrication was never the problem. The problem was they never fitted the right kind of valve spring suitable for the radical camshafts that they were using. Yesterday I mentioned Brian Hart, and I was mistaken in what I said, and I realised today, because I referred to his 420R in respect of Ricardo doing valve design research for him. Of course, it wasn't the 420R, it was the 830R, which was the 1030R, the 10-cylinder V8 3 litre with which Hart achieved his highest ever result with Repsol, Tolman Hart, if you remember, second at Monaco. Made a lot of money with that, and well done Harty. He reinvested it in the company, bought ultrasonic machine, CNC lathes, CNC milling machines. Well done him. Now that engine was on the limit insofar as conventional valve springs were concerned. It was on the limit of what the springs could cope with for the camshaft lift they were using. I don't actually know what camshaft lift they were using, but believe me, it would have been radical. This is a four valves per cylinder engine, a V10, probably revving to something like 13, maybe 14,000 RPM. And the valve spring couldn't cope, which is why Hart, I do believe this, some anecdotal evidence to prove it out, but Harty, bless him, is dead some years hence, God rest his soul. Top man, giant, archetypal F1 boss, terrifying man to work with, but we all loved him because he was Harty and he paid so well, and he was really a terrific man to have known. Harty turned to Ricardo. Ricardo came up with the strongest spring pack known to man. You've never seen anything like it. The springs were so hard that they suffered failures in the material because they were on the limit of spring steel technology, absolutely on the limit. Now, steel, being a ferrous material, does not suffer from fatigue. Fatigue is well understood in materials like titanium and aluminum, where you have a stress, number of cycles, predictable end to failure for that material for its level of duty. Steel is different. Steel and other ferrous materials have a thing known as what's it called now? Not fatigue limit. It'll come to me in a second. Anyway, they exceeded it. Endurance limit, that's it. Now, I know how to calculate endurance limits for steels and ferrous materials, and it's not that complicated, but the fact is, if you go so much as 1 megapascal over that limit, that steel will fracture, and that's exactly what happened. It was deduced, and I won't say Harty was behind this, it was deduced, as with the Vauxhall HSR, with its cross-drilled camshafts, that the problem was inadequate lubrication to the spring. So Harty decided to take the little wire nets out of the valve drains in the cylinder head to improve the flow down to the sump, so the dry sump could pump more and faster around the camshaft. What happened then? When the spring tang, that's the end of the spring here, the weakest point where it's quite thin, when that fractured, went into the sump and straight through the scavenge pumps, trashed the scavenge pumps and the whole engine. Solution, they thought? Put oil sprays onto the cam followers. And it's something they carried forward onto later generations. When I joined them in the late 90s, they had a contract with Minardi for one of the first micro V8 engines. They had oil sprays all over the place. But by that time, Del West in the United States had pioneered what they called rather colloquially air valve technology, because it didn't use air, it used nitrogen to pressurise these little systems. So they were like tiny little piston systems instead of a conventional cam follower and spring that were pumped up. It was a closed system, so it had a tiny little nitrogen bottle on the end of the engine, and compressed nitrogen was used as the medium which would otherwise have been a spring. In terms of spring behaviour, it is important that the spring is retained in place by a spring base that sits on the spring platform on the head. Now, here's a standard Fiat spring base, 2 parts. The outer spring sits on here, and the inner spring clips neatly onto this little stepped one. I myself use a racing spring base which I designed, a very, very tricky thing to make. Very easy to make it sharp when you're fitting it to the spring. When I first had them in, I was trying to clip them onto the spring like this, because it clips onto the inner spring here, and I cut my palm open, so I changed the drawing and made absolutely sure no sharp edges. And the reason for needing these is if you don't have adequate spring base protection, the base of the spring wanders like this, and that was part of the problem with the HSR, and I've seen it on other engines too. You cannot rely on the valve guide, especially if it's a copper alloy, bronze. You can't rely on the valve guide to keep the spring positioned concentric with the valve, because, well, hello, valve steel, copper alloy, cast iron are soft and they wear each other out. So without adequate spring base control, spring does this, and wear is sure to follow. In the extreme, the spring can rub on the camshaft follower itself, which is degrading, and I've seen all these things. So moving on again, and I dare say I'll make future reference to springs in the future. Here's a GC camshaft for an 8-valve Fiat. Key features, right? Here's the lobe. Here are the journals. 1, 2, 3, 4 journals, and a flange at the end to stop the thing drifting backwards and forwards. The journals are grooved to improve the oil distribution around the journal, which comes up through the cylinder head. 4 lobes. Key features of the lobe. Here's the base circle. Part of that bit that you can see where my finger is actually round, and here, if you can see it, well, find something to point with. Let's use this caliper, try not to drop it. Somewhere between here and the base circle and the opening or closing flank is that critical bit I spoke about yesterday called the ramp, which permits the valve to move smoothly, progressively, albeit bloody fast, onto the opening or closing phase. I've probably got the camshaft back to front, but the point is still valid. Here is the lift radius, and in the case of the Fiat twin cam, because the camshaft is inside a housing of a certain diameter, the lift radius cannot be bigger than the centre main journal radius, because otherwise camshaft won't fit in the housing. And the way that extra lift is developed on a camshaft, compare and contrast for a moment with a very worn 16-valve camshaft. See the base circle on there relative to the axis of the camshaft. See how it sticks out below the main part of the casting. Quite a lot of base circle there, big base circle. Hardly any base circle there at all. If we grind too much off the base circle, what will happen is that the camshaft follower will rub on the camshaft. So we are constrained as to the diameter of the base circle, and we are constrained as to the lift radius to get it through the housing. Therefore, the amount of lift that you can generate on a camshaft for a Fiat twin cam is very finite, because it goes through a housing. The same cannot be true of the 16-valve and many other engines where the available space for the nose radius is unlimited. Reground camshafts, what do? Well, they take a standard camshaft. This is again a 16-valve example for what it's worth. they grind material off the base circle, and therefore in effect you can bring the valve tip closer to the base circle and take up the clearance with a top hat shim or whatever, or machine the valve seat for the valves deeper into the head so it's closer to the cam. If you reduce the base circle, you automatically increase the lift. Okay? So this is made of extremely high quality cast iron, which is the dream material for a camshaft. You may think steel is better. Well, steel is good if it's properly heat treated, plasma nitrided, carburized, etc. Properly stress relieved, made by a reputable manufacturer. Steel is fine, except that in extremes, problems with fueling, start-up issues with lubrication. Once you wear off the coating, what have you got underneath? Bare steel. Now, bare steel is quite simply the worst material on earth to run against a hardened follower, because it has no coating, no tribological protection at all. There's a big word for you. Tribology, a subject I know intensely well, long before the days before they tried to develop mathematics to make it a science. I knew a lot about tribology, and I was a tribology expert at Napier turbochargers, so look up tribology. Here is a steel, no, I'm wrong, or am I right? No, here's a copy of a GC camshaft, and it is not as hard as my camshaft. And you can see that the, oh, I tell a lie, no, I'm completely wrong. This is, oh, I'm glad I brought this home. This is the famous Colombo and Bariani steel camshaft that caused me all the problems you may have read about on my forum, guy-croft.com, where Mr. Bariani, of his own volition, decided not to heat treat the camshaft. This camshaft is as soft as mild steel. I had it tested by 2 heat treatment agencies and Piper camshafts themselves, and technical director John Crabb rang me up and said, it's got no hardness at all, it's as soft as shit, which is why it wore out in about half a minute on an 8-valve Lancia Integrale owned by a respected client of mine called Tom Frame. So it looks the bollocks, it really does, it's beautifully finished, but it's as soft as shit and absolutely fucking useless. Colombo and Bariani. Tried to get recompense from them, got virtually fuck all, and they're probably still making them, and they're still respected all over the world as Italy's top camshaft manufacturer. I don't want to say too much about this, except to say, buyer beware. Looks great, fucking useless. For a long period, I'm sad to say, Fiat, bless them, who are normally very good at this stuff, produced camshafts for the 16-valve Integrale where either the material or the heat treatment applied to the camshaft was insufficient. Can you see how pointy the lobe is on this pair compared with this pair? A sure test of whether a camshaft is worn or not is just rub your finger over the nose. If it feels pointy, it's probably worn. This is pointy like, whoa, it's gone completely pear-shaped. If you look at it closely, I don't know if you can see the striations and wear marks. It's not common to every lobe, but generally speaking, and that's a cast iron cam, when you're making a cast iron camshaft, the best way to do it is a method known as chill casting, where as soon as the cast iron cam comes out of the mould where it's poured, you place iron blocks against the bits that you want to be hard and you supercool it very quickly, and it's highly effective. Naturally, excuse the noises off, it's me being clumsy. That's probably a client's camshaft I've banged on the bench there. Naturally, you want a good grade of cast iron, so it's going to be, it's going to have a high molybdenum silicon content, it's going to be spheroidal graphite or whatever, and get all those things together. Your camshaft will last almost indefinitely, provided you give it good start-up lubrication and some molybdenum grease or something of that kind prior to cranking up oil pressure. Don't use graphite on camshafts. I mean, I used to, and I got away with it. I think I might have even recommended it in my 95 book. I learned subsequently, excuse me, the throat's going dry, talking too much, need a drink. I learned subsequently in a report that I read when I was a chief engineer with Napier, that NASA had discovered that cast iron, which all the Fiat camshafts were made of, and virtually every camshaft on the planet on production end is made of cast iron these days, has an affinity. In other words, it likes aluminum in the presence of graphite. And graphite at that time, and we're going back probably to, I don't know, late 90s, was dropped as a lubrication medium by American aerospace industries in favour of molybdenum, or molybdenum disulfide, or things of that kind. And all good quality engine build lubricants, whether they be dry or liquid, and particularly for camshaft pre-start running, contain molybdenum, which is frankly about the best lubrication medium in the world. Try beeswax, Vaseline, whatever you like, but I go with molybdenum. Molybdenum grease from a can, perfectly good enough. So what else can I tell you from this little collection of bits and pieces? Not much by this time, but I will move on to something else, and it's a subject which is easy to understand but very much misunderstood, and that is, why do you want adjustable cam pulleys, and what is wrong with standard pulleys when you've got a competition camshaft? I'll talk more about camshafts on another session, perhaps tomorrow. And the fact is, when you set up a camshaft, you do it on the bench on the cylinder head. So you dial in the camshaft in order that you get inlet and exhaust full lift at the right place in the engine operating cycle. So that might mean when you come to put ye olde standard cam pulley, or sprocket if it's chain driven, on the engine, hello, the belt teeth won't line up with the teeth on the pulley, right? Lined up, not lined up. Got it? You want to see that again? Right, all you guys all over the world who don't want to buy adjustable cam pulleys because you don't think you need them, right? Belt lines up, belt doesn't line up. And what do most people do? Well, they just move the camshaft a bit so the belt lines up. Well, what price camshaft timing? And if you turn it the wrong way, you bring the valve closer to the piston at top centre or around top centre. The actual closest proximity of the valve to the piston is not in fact at top centre on any engine. In the case of the inlet valve, it's somewhere around 15 to 18 degrees after, crank degrees after top centre, and conversely on the exhaust cycle, somewhere between 15 and 18 degrees before top centre. So you go swinging the cam pulley around to get the belt on, you buggered your cam timing and you'll probably clash a valve. Whereas with this device, if your belt doesn't line up, you just undo the nuts and bolts, turn the outer hub, hey presto, belt fits. Tension the belt, perfect, easy. So adjustable cam pulleys. People call them vernier pulleys. There's no vernier scale on this pulley, right? This is a vernier caliper. I'll switch it on. Find the right button. Vernier caliper. Well, actually, it's a digital caliper. It's not really a vernier. I don't like old-fashioned verniers. In fact, I'm completely wrong. It's not a vernier caliper at all. Vernier calipers, you've got those ridiculously tiny scales, like on calipers and micrometers, where I need a bloody microscope to read them these days. I hate the damn things. But you don't need a vernier to get the belt on. If you want to play around with your camshaft timing on dyno tests, well, yeah, vernier cam wheels are great, because you can say, right, I'm going to move the inlet cam 1 degree, open it more. I'm going to change the lobe centerline angle. I'll come on to these things at another juncture. I'm losing my voice here, probably losing my marbles as well with this fucking COVID virus. I'm trapped in my house like a rabbit down a hole. But the great danger of doing a dyno swing with cam testing is what's going to happen to your valve to piston proximity? Because that closest point, and I told you what that is earlier, it's not top center. You got to have, crikey, depends on your valve springs. You got to have 60 thou, that's 1.5 mil, preferably 2 millimeters, maybe more between valve and piston in the vertical plane, right? So here's your inclined valve, there's the valve relief, right? In that plane, never mind radial clearance. You go swinging a cam around on the dyno without having pre-mapped the lift characteristic of your valve, you're in serious trouble. I don't like vernier cam wheels at all for that reason, because people think they're the panacea.